You're concerned of your camera overheating while you're recording, or even worse, while you're live streaming. These can tend to get really hot, or I have got a solution that should avoid the camera from overheating.
Camera wins, all right? The camera wins in what it wants, because it told me, hey, Strick, you have the room too hot for me to operate.
It just got too hot. It really got too hot. And like even right now, my camera says it's overheating, but I have a fan. It has a specific fan, a fancy fan I bought for it.
The idea is I'll mark the point, take those temperatures while the camera's cool, as in off, then put the cameras on, run them for 2 hours. After that, implement the goodies in this. Now, this isn't an off-the-shelf camera cooling kit. This is something I'm going to hack together, but the logic being that this should be able to run cooler and quieter and avoid the camera from overheating. Now, I've already got things like the door open. If you are having temperature problems, get things like, if you have got a dummy battery, open the door, leave the door open. If you've got your screen, have that off the back. So the more stuff you can move or open, the better it's going to be for releasing the temperature off the camera. On this side, you'll see I've got the flap door open from the bottom of the camera where the battery door is. I want to take the temperature from 3 points there, temperature above the dial, from the top mount and also the bottom mount where the lens ring is. Once I've done that, and again I'm measuring it with my current settings, so I'll do a zoom on this with this, as I said, with the screens and the battery bay open. If another thing I've done previously is if I go to this camera setup here on the SD card, I actually use this, which actually extends my SD. And the idea is that is if there is any heat and temperature going to the SD card, the SD card is out. And originally I had 2 monitors butted right against there, and I couldn't reach the SD card, so I had the SD card above the camera so I could actually reach it. I've tried to do everything to keep as much as the temperature away from the camera. Again, the screen's up on that. This is actually a small office, no windows or direct ventilation. Switched on both monitors. The computer is now on. Activated the live software. I actually use something called Ecamm for live streaming and recording most of my videos with Ecamm. If you can see there, I have the top-down view, I have the front camera, I also have the teleprompter, so all screens are on. So this would be a typical setup. The temperature increase, be it summer or be it winter, would be this set of gear being turned on, sending all the heat upwards to that camera. Not intentionally, it's heat rising. So what I'll do, set an alarm for 2 hours, come back and then measure what increase we've had on those. I'm using the Shure microphone, so obviously a microphone that is more sensitive than the Shure is almost certain to be picking up. So that's the sound. If you can hear the fan, I am currently about 2.5 feet away from the fan. So doing the temperature testing in a controlled environment, which is my office, is fine. Let's see how it is out here. Now this is basically a sun trap. I have something running to the side here and this just heats up, and then we've got the studio behind me. I've got the camera set up there, and let's see how hot that's going to get. But let's first see the temperature of this environment. I don't know if you can see that. So the temperature in is where I'm standing now, and the temperature out is the studio. So we're about 35°C. I'll put the Fahrenheit up because us over here we use C. So I'm going to see what the Fahrenheit on the screen. So now let's go to where I'm going to run this test. So at the moment I've got this set up here. I've taken the temperature of the camera cold. So same as what I did in the office, I've measured the various points. So you can see I'm pulling in a full screen display there. So I'm actually capturing it through a HDMI capture on this is an old Mac. If you can hear anything, it's not the fan in the room, it's actually the fan on the MacBook. It's actually toasty. That's what I'm pulling in. So I'm pulling in a display. Again, this would normally be through streaming software like Ecamm or OBS or something like that. Okay, it's been a few hours since I actually finished recording all the temperatures. It's actually a bit cooler now, so I can actually stand here. So I've recorded the temperature when the camera was cold, After the camera had been running for about an hour and 10 minutes, I got distracted by a customer call, and then I set up the fan, then recorded it after it had been running for a further half hour. So the camera's been continually on, and this was, so it's about, and the temperature was after the camera had been running an hour and a half an hour with the fan on it. So I will post those findings.
So what was the results of all these tests? So this is the test that was done in here. So the Sony in the office, it had been in the office, all the time, but so it certainly used to be in this office, and it had the room temperature, which we can see here after it been running for 2 hours. So I'd set that up using Ecamm live streaming software. I'll leave a link in the description. You can see the temperature has gone up. This is a small room. There's no real ventilation on it, so the heat does build up here, particularly up there where that camera is. So we can see we've got increases of temperature. Percentage wise, the main 3 points I'm looking at is the back of the camera. So that is 0.2, 0.3 and 0.5. You can see those increases in those temperatures at 61% on 0.2, 90%. That's bang in the middle of the camera, where at the back of the screen once it's opened up, and then 0.5. So you can see those increases in temperature. Turning on the fan. Yeah, some might say, as you can see, look at the results, they are down. You might say, I can get these little fans that you stick on the, I use the word stick because most of them fall off. And they've had all sorts where you can put a little plastic film on the back of the camera and then sucker tape it to it, or put clips around it. Basically, they are really small fans. They don't move a lot of air, and they make a considerable amount of noise. If anybody knows any difference, by all means, send it into them. I'm quite willing to test them. I should say they're known for being quiet and efficient. You can buy cheaper fans. You will pay dearly because they'll make more noise. So a quality fan, these are not expensive. I will leave links to them in the comments and descriptions below. But look at the temperature drops all the way down. There's a temperature drop, and percentage wise, I mean, the main one is 32%. Sorry, 32.7 on the back of the camera, dropping that temperature down. Only where are we? 6 degrees higher with this versus the camera being off. So only a 6-degree increase. Now let's go out to the studio, which is considerably warmer. Now out in the studio, the starting temperatures are obviously high. So if I just go back, we're going from 23.1 to 33. 0.3 was 23 starting. It's starting at 34. It was warm out there. So running the camera for 2 hours. I'd run it for an hour a bit, and then a bit longer than an hour and 10 minutes because I got dragged away on a business call. So it was just over 2 hours in total. So we can see the temperature increases are, I just want to see that. Yeah, that wasn't too bad there. So temperature increases, we have going up to 38 on 0.3. 0.2 had gone to 49. 0.5, let me see, had gone to 37. So percentage increase, 7, 48, 10%. I wonder if having 2 fans, I might reach out to the manufacturer and ask for some of their technical data. If I'd run 2 fans in clamshell, how would that potentially work? So overall temperatures with the fan, there's dropped from starting at 33. When it was running, it gone up to 36. The temperature now is dropped below the starting point. That's really interesting. So the temperature that after it been running is cooler than it was when it wasn't on. It's gone down. So 0.2's gone to, I'm looking at the starting temperature was 33. Then it went up to 49. It's in Celsius. And then it's gone to 31. Again, cooler than the starting temperature. 0.3, about the same as starting temperature, but definitely down when it's been running. So I'll leave these results so you can go through, but they have come down, and in some cases, because the environment was really hot, it's actually cooler than when it was off. So these are the temperatures down there, so you can see that there. I will leave links to the gear and web page where I'm just going to put a document of all of this in the descriptions. Now if we move to the fan setup, so the brand of fan is, let me just check that's in focus, is Noctua. You have a black version of this, but this is the one that everybody knows them for, this particular colour. They're not looking to be fancy, they're looking to be efficient. Nice looking fan, really. It's different. As you can see, if I can have that in there, you can see it's blowing at the back of the fan. Sorry, blowing at the back of the camera and across the front of the camera, generally helping to keep the lens around here. This is a metal finish. It's probably be slightly different if it's plastic, but this metal actually cool down, which actually helps draw heat. So the heat is being drawn and this is cooling it down, as well as the back of the camera. This is generally where the heat is really building up, at the back there. So getting that cooled down. Again, I did cover it in the video. Get everything going where you can. The battery bay, the camera screen. So the kit itself, what do you need? So you're going to need the fan. I'll come to the small rig in a moment. That's the fan. Now there's a couple of sizes. This is the 120, the standard PC. There is a 200. I'll show you that in a moment. It comes with this lead. So if we open a box, that's the box. Within the box, you're going to see they do supply screws, but they would much prefer you not to use the screws, because this would go into the case. And if I can show you that, you'll see that's like a rubber grommet type device. So that would go in there, pull, and you'd actually connect that to your case using this, which, if you imagine, you've got 4 of these and these are bouncing on the case. So these are the, for want of a better word, shock absorbers. So if there's any noise or frequency coming from the fan, these little grommets or plug things will be taking up that noise. Bit like when you get the shock absorbers on the speakers to take in the noise. So that's them. Within that comes this lead. Now there's a USB lead. There's also a USB regulator. If I show you what that looks like. So on their website, that's the regulator where you would plug in the cable and the USB would come out, and then you can actually regulate the amount of power going to your fan. There's the fan itself. So this is a 120. They've got a whole host of fans. They've also got a 200. Now, I used to have a big 200 in my other case, and that was massive. Now, interestingly, the bigger the fan, the less noise they tend to make. So this one used to be so in the case, and it was a mesh case, and that would help cool that case. I think I had that one for about 12, 13 years. Anyway, so that if you were doing live production and you had maybe a big rig you want to cool down, if you imagine if you've got somebody on stage 50 yards away or whatever, and you've got this keeping your camera cool, they're not going to hear that. They're going to be mic'd up on stage. So this could be really useful if you're using particular cameras that tend to overheat and you're on stage or in a production environment. These are going to be perfect. You can have that. They could be cooling your kit down or keeping your kit cool. So back to the overhead. So yes, you've got these rubber grommets. I might speak to somebody on YouTube I know who's doing gear, who's going to be doing a lot of camera gear, and he's got a 3D printer. So they might be able to create a case version that could be mounted with some kind of standard tripod mounts. And then this fan could be mounted to that. I'll reach out to them anyway. So you're going to obviously need the fan. That's the 120. I said they've got bigger. Then we've got this. So within this particular kit, there's the one clamp. So I'll leave a link to that. And in fairness, you're probably going to need an additional clamp for that, because I think I brought an extra clamp. So you're going to need one of these, unless you've got somewhere else or some other method of mounting it, and then another clamp to go with that, and then potentially power. Either a USB. I would go with a USB extension lead if you go into a USB socket. That's what I used on the headboard on the bed. On this one, I used the power into this, and outside I used this, and then eventually, when I've been streaming from that location, I've actually been using a USB extension lead into a wall adapter to get the power. So that's what you're going to need kit wise. I'll leave a link to all of them in the description.